Okay, once sir come, he will
Hmm.
record in cloud, ma'am.
Okay.
Okay. Okay, students. So we were going to start the third unit. Before starting the third unit, I think the first day of the class. Good morning to all, ma. The first day of the class, I told you the course objectives and course outcome. I think you can clearly view our syllabus. So the unit 1, DC circuits, direct current circuits, we have discussed. Okay, before discussing about unit 1, we have seen what is our course objective. We all know your department is a NB accredited department. So why you are learning this course is very, very important. So first thing is to impart knowledge on the analysis of DC and AC circuits. So the first thing we covered the course objective in first 2 units. I hope you all have learned about all the DC circuits and AC circuits, and you have know how to solve the circuits and all. So we have completed our first course objective of your course. Okay. The second course objective is gain knowledge about the magnetic circuits. So you are in the second step of your course objective to gain knowledge about the magnetic circuit. That is your unit 3. So the entire unit 3, you are going to learn about the magnetic circuits. Okay. So this is your first course objective we have successfully completed, and we are going to enter into the second course objective to gain the knowledge about the magnetic circuits. Okay, so the entire unit you are going to learn about magnet. And you may ask, ma'am, already we have studied about the magnetic circuit. What is the new thing we are going to learn? Actually, you will learn about magnetic circuit, and this particular magnetic circuit, whatever the fundamental definitions you are learned in your earlier version, the same thing you are going to learn, and you are going to correlate with the electric circuit, and you are going to know the importance of the magnetic circuit. That is very, very important. And you just people go through the course outcome. You all know CO means course outcome. The first unit covers CO1, second unit CO2, third unit CO3, fourth unit CO4, and fifth unit is obviously its applications. So CO5 and CO6 will be covered in your fifth unit. Okay. So we have completed our CO1. Analyze electric circuit using Kirchhoff's law. I think you have studied about the revision on unit 1 and unit 2, please. We will do unit 1 and unit 2 definitely. Today actually the third unit is very, very simple while you're comparing to first 2 units, because you people have to submit the assignment also. So we will complete the third unit next week itself. Okay, this week I'm having 2 hours, and the next week it will very, very simple unit, because so far we have crossed nearly some 25 22 23 hours. We have completed only 2 units, but you see 9 hours 18 hours only they allocated. So what we will do, we complete the third unit, and meanwhile you will submit your assignments. Then we will definitely give the revisions on the first 2 units. Then only we will move on to fourth and fifth. Are you clear? Because I told you the first 3 unit is about electrical circuits, and fourth and fifth is about magnetic circuit. And one more thing, there is no correlation between the third, that is if you use the magnetic circuits, you don't have any baggage on the first 2 units. So this is the new unit. So students kindly listen to the units, because it's a very simple unit. Your voice is not clear. Yeah, ma'am, my voice is not clear. Huh?
No, ma'am, you're audible. Okay.
Yeah,
Clear,
Sushant,
okay.
you check your net connection. I think some of the time you don't have a proper net, you have this kind of error. Okay, yeah. So students, we will definitely give. So once we complete the third unit, we give the we will give the revisions in first 2 units. Definitely we will allocate 1 week to revise the first 2 units. Are you clear, ma? Okay. And yesterday I have put the first unit PPT, second unit PPT, and the important formulas PPT. So my kind advice is, whatever I have put it in important formula, please kindly go through it and learn all the formulas, because I told you repeatedly, I am saying the first unit if you take, you see the very important part being a mesh and node analysis only. So definitely the problem will come in first unit. First unit you don't have any theory question in part B. definitely they will ask problems only. Whether the problems in reduction of resistors or mesh or nodal. Only these three kind of problems you are supposed to solve. So the first unit and the second unit, I gave you the probable 7 theory questions. Apart from that, they may ask problems. Okay, are you clear? So second unit, you may have a problem as well as theoretical part. So alternating circuit, comparing with first unit, the second unit have some lengthy syllabus because we will learn what is the basic fundamental sinusoidal RMS, and then only we enter into the resistive, inductive, and capacitive circuit, and then we learn all about the combination of RL, RC, and RLC. Then we learn about three phase. Okay. Now I am going to move on to unit 3. You just see CO1. What's the course outcome 1 covers now? Analyze electrical circuit using Kirchhoff's law. We covered that. Okay. CO2. What is our course outcome 2 now? Compare the behavior of R, L, and C and their combinations in AC circuits. Yeah, I have. That's why I put it on tabular column. Pure R, pure L, pure C. We have compared, and then we go with the combination of RL, RC, and RLC, and we have studied how the circuit is behaving and all. Okay. The third unit is understand the concepts of magnetic circuits. You all understand. We are going to learn only how the magnetic circuit is working. So we are going to learn the CO3. Okay, understand the concepts of magnetic circuit. And yesterday asked, some of you asked the reference book. Actually, the problem, what we solved in the class and what we gave the problem to practice. And in LMS also, some of the problem have put it for practice. That and all very, very sufficient for you to practice. Even if you want to know well in electrical circuit, you may go through on this. And my kind of advice is the first 2 unit only covers the 3 unit, the remaining and all electronic circuits only. So Aravind Mittal, Tereja and all, you can refer it. I think you are all well versed in Google. So you have a Google Books option. So students want to practice more problem, you can solve that, or else whatever we gave it in the PPT and whatever we gave the problem to practice, that is all sufficient for you. Are you clear, ma'am? Okay. Now I will enter into the unit 3 and we will see, yeah, the strength is around 206. Okay. And yeah. Unit 3, magnetic circuit. Okay. So definition of MMF, flux, reluctance, electromagnetic induction, Fleming's rule, Lenz's law, Faraday's law, statically and dynamically induced EMF, self and mutual inductance, analogy of electric and magnetic circuits. I think all these words somewhat familiar and you have heard wherever there, but this is our unit 3 syllabus. Okay. So I think all our technical terms related to magnetic circuits and where we are going to apply this magnetic circuits law and how we are going to compare the electric circuit and magnetic circuit. Are you clear? Ma'am, these reference books are available in our library. Yeah, definitely. Still Lokesh voice is breaking. Why I am getting the doubt, ma voice is breaking, ma'am?
No,
Boneshwari,
no,
ma'am?
it is okay only. I
Yeah.
think yes, some bandwidth problem.
Yeah, please students check your net connection. That is very important. If your net connection is not proper, then automatically you have the problem. Okay. Now I think you are all before entering into magnetic circuit. What is the source of magnetic circuit? We all know the magnet will or a material. It's a material where it produces a magnetic field. But we all know how we can't able to visualize the current. It is invisible. Similarly, magnetic field is also invisible. But according to the property of the magnetic field, we can able to attract or repel. That is the property we can able to see. But the magnetic field is invisible to you. So what are the types of magnet available? I think what are the types of magnetic that we can say? Temporary magnet, permanent magnet, and electromagnet. These are the sources of magnet we can categorize. Okay. And temporary magnet. Temporary magnet means in the presence of magnetic field only, this temporary magnet will be magnetized, and automatically it will lose its magnetism gradually when the magnetic field is removed. So the temporary magnet means whenever it gains the magnetic field when the magnet is available near to it. When it is removed, it will lose. So the name itself we can understand it's a temporary magnet. Okay. Then permanent magnet. We all know the permanent magnet is available in the earth, and I'm getting electric flux. Yeah. Permanent magnet. We will move on to that terminology and all. So permanent magnet which is available yeah, in the earth, but it is a rare element or some chemical component we can form. So automatically what happen, it's retain its magnetism even the magnetic field is removed. Okay. But we were all focusing on electromagnets. Our entire unit, we can't able to go with the temporary magnets, we can't go with the permanent magnet. We all focusing on electromagnets. So what is electromagnet? Means when I take any magnetic material, I will wound a coil around the magnetic material. Okay, it's a nothing but an electric coil. Okay, and I will pass the current through the magnetic material, and automatically what happen, it will experience a magnetic field around the coil. When the supply is removed or the current is shut off, automatically what happen, the magnetic field will be disappear. So this electromagnet concept only we were applying in all electrical machines. Okay, so electromagnet means a coil of wire where I will wound around the magnetic material. I will pass the current through that, then automatically the magnetic field will be created around that. So when I stops the current flowing through the coil, automatically it the magnetic field will be disappear. I told you the so many applications they were in our day-to-day life. When you see that electromagnet means all our electrical machines, railroad tracks, in MRI machines, cranes and all, they were using this electromagnet material. So what happened, they are using some ferromagnetic material, some such as steel, cast iron and all. We will wound the coil around that, we will pass the current, then a DC current, then automatically it will gain the magnetic field around it. Okay, now we are going to start know what is magnetic field, why it is necessary. You all understand why we are going to learn magnetic field here, because the first unit you learn about all direct current and all, and the second unit alternating current. But why we are learning magnetic field now, you have to understand the interaction of electric and magnetic field only the energy conversion will take place. Otherwise the energy conversion will not take. Any electrical machine which is working under the principle of motor or generator or any transformer or anything, if any energy conversion want to take place, the interaction of electric and magnetic field is very important. You just see this figure. This is my motor principle. Okay, a current carrying conductor is placed in a magnetic field, it experiences a force. You just see this is my coil, okay, which carries the current. Okay, it is placed under the magnetic field. Leave it. I told you maximum we were using electromagnets only in our applications. Okay, so what happened now? It will. This is a one steel or cast iron or ferromagnetic material. I will wound the coil around this, and I will pass the DC current. Then automatically magnetic field will be created. I think there's a yellow color line there. Sorry, this red color line they are indicating that is a magnetic field. So you just see my coil is rotating around this magnetic field. You just see the force. You have seen the green color which indicates the force direction. We all know F equal to BLV sin theta. You have studied that, the force experience. So you all understand a current carrying means motor means what, we will apply the electrical energy. So a current carrying conductor is placed in a magnetic field, it experiences a force. That's why my electrical energy is converted into mechanical energy. Naveen Kumar, any doubt, you kindly post in the chat. Okay. Okay, so you have to know the interaction of electric and a magnetic field only. The energy conversion is taking place. All you understand? Now you come into the point generator principle. Okay, now you all know the generator in layman, it will convert the mechanical energy into electrical energy. So here you just see my conductor is rotated in a uniform magnetic field and EMF is induced. That is the Faraday's law of electromagnetic induction. Okay, so you just see the flux linking a coil is changes. So we all know what is Faraday's law of electromagnetic induction. Can anyone tell that equation? I think it's a very popular equation. Yeah, Manoj. Yeah, I'm getting the answers also. Yeah. Very good. Shri Teja, Gautam, and all you put d5 by dt due to rate of change of flux and EMF is induced and it depends on number of turns. Actually, here it refers they have taken a single turn coil. So you just see definitely my conductor is rotated in a uniform magnetic field and EMF is induced. You just see an EMF that is indicated by this direction and that is generator principle. And you all move on to transformer. I think I'm getting LDI by dt. Yeah, that is the next phase of this. So I'm not going in detail about that. Before to know the importance of magnetic field, I have taken some of the machine. You just see this is my transformer. You have seen my primary is connected to the AC supply and my secondary winding I have connected to the load, and we will give the supply to the primary. You all know this two primary and secondary winding, you all know according to the transformer, this will be electrically separated but magnetically coupled. But the EMF will be induced due to the electromagnetic induction principle. The EMF will be induced. But in this working, you have seen the conductor is stationary. Actually, you are seeing, but the magnetic flux is varying. So automatically the EMF is induced in the coil. So here also you see without electric, with electric field, I'm not stepping up or stepping down the voltage. Definitely I need a magnetic field. Even though the coil is separated, but magnetically coupled, my voltage will be given to the secondary winding. If the number of turns get increased, it is a step up transformer. If number of turns decreased in the secondary winding, it is a step down transformer. Okay, so you have understand that a magnetic field is very mandatory, very mandatory if any energy conversion wants to take place. With electric field, never the energy conversion takes place. So when you take any machine, whether it may be a motor, we all know the fundamental machines are motor, generator, transformer and all. So all the machines I'm stating that both electric field and magnetic field are very mandatory, and the interaction of both the electric and magnetic field only the energy conversion will take place, whether it may be a electrical to mechanical or mechanical to electrical, or we have to step up or step down the voltage. All our principles are needed only by the mean of. So the magnetic field concept is very important. So learning alone electric concepts are not enough to know about the basic electrical thing. The magnetic field is also very enough, very mandatory for you. Are you clear, ma? So that's why I have taken this thing. You have seen that motor, generator, and you have seen my flux is also changing and automatically an EMF induced. Okay. Now today what we are going to see now, some basic definitions. Okay, whatever I'm teaching from here till this end, all are 2 marks. You all know definitely you have a weightage for each unit is 20 marks. I already told you. Part A, definitely they will ask 2 marks. So 2 into 2, 4 marks. And one part B question which consisting of 16 marks. So 16 plus 4, 20 marks is mandatory. So my kind advice is not only this subject, for all the subjects, don't skip any unit. If you skip one unit, definitely you will lose 20 marks. So try to learn all the units, because 5 into 20, we will cover 100 marks in your external examination. Okay, so my kind advice is, this unit is very simple comparing to other unit. So people, kindly note down the formulas what I am writing. Anyway, I will consolidate the formula at the last, but you try to listen what are the formulas. Some of them were learning at first, or some of them were learn already the formula, depending on your curriculum what you learn it before. But my advice is, take down the formulas. Okay, I think you people were following one notebook, because this subject is for that very mandatory. Okay, and we all know the magnetic property. The poles will repel, like poles will be repel each other, and unlike poles will attract each other. And we all know, it will be the point at which iron pieces accumulated maximum are called poles of the magnet, that we used to say north pole and south pole. So the imaginary line joining these poles are called as a axis of the magnet. We can't able to view that, I told you already. The magnetic field will be invisible, and we all know we can experience it, but we can't able to visible it. Okay, and the magnetic induction principle, we all know, any piece of magnetic material which placed near the magnet, which induce the physical contact, that will be called as a magnetic induction. And what is magnetic field? A field or a force surrounding a permanent magnet or a moving charged particle. The field around that magnetic medium will be called as a magnetic field. So when I place any charge around that magnetic field, it experiences a force. That's I told you in the motor principle. Whenever a current carrying conductor placed in a magnetic field, it experiences a force. So that's they are saying. Okay, and you have seen the magnetic lines of force. I told you this is the two poles, no, north and south pole. So automatically you have seen, that is, this is the magnetic lines of force. So whether in north pole the magnetic lines of force will be outward, and south pole it will be inwards. This is already you learned. So this magnetic field which connects here, so automatically if I brought in this magnetic field any charged conductor, then automatically it will rotate. I think you have done in your school experiments and all. That is actually motor principle. But we were creating a large magnetic medium with a large number of conductors. We were creating the motor principle. But this is the simple principle. You all know the Faraday's, which invented, where we have developed so many machines. Even though the motor generator, now we have all automated vision of motors and all were working with the same principle. Faraday's law, Fleming's left hand rule, right hand rule, all are based on this only. The force direction, EMF direction, the rotation of the conductors, everything will be based on that law. So these are the very fundamental law. These are very mandatory law. We have to know the energy conversion and the direction. Okay, and now we were going into this. From this onwards, you can expect, these are the basic thing we have discussed. This onwards you can expect the two more questions. Okay, so you people have seen this. So you have seen bar magnet or whatever, maybe I have drawn the lines of magnet, and I told you this is, you can consider is it's a temporary magnet or permanent magnet or electromagnet, whatever may be. It will the magnetic field will be, the magnetic lines will be around it. That is nothing but a magnetic lines of force. Okay, now what is flux? What is relating the flux? The total number of lines exist in a particular magnetic field is called magnetic flux. You all know the magnetic flux definition. You all know what is flux and all. But you people have to understand the total number of lines existing in a particular magnetic field is called magnetic flux. So the symbol for fluxes, I think you have studied. This is phi. Okay, phi. I think can you able to view in your screen? This is the symbol for flux. You have a, whatever I'm solving in a problem, if I put phi, you have to know it is a magnetic flux. Okay. What is the unit? Weber. You all the unit is Weber, and you all know the Weber is the highest unit. What is the one Weber value? You have seen 10 power 8 lines of force. You have seen how long my the Weber is the largest unit. So when you solve any problem, it will be in a milliweber or microweber only. If you're having Weber in thousand and all, your calculation is wrong. Can you understand or not? It will be happen only in a large machines and all. But you see, normally the Weber is a largest unit because my one Weber value will be equal to 10 power 8 lines of force. So I think you people kindly note down this definition. Yeah, Sai Kumar have put phi equal to b into a, e equal to, yeah, you people are I told you this unit will be very enjoying for you because you have already learned what you have studied. So I think this is the definition for magnetic flux. Total number of lines existing in a particular magnetic field is called magnetic flux. Okay. Now, pole strength, I told you already. uh, every pole has a capacity to radiate or accept. You all know radiate will be the north pole, accept will be the south pole, with the number of magnetic lines of force. That is called as a pole strength. Okay, you have to know what is pole strength. And a magnetic flux density. What is magnetic flux density? I think now the people have put phi equal to b into a. You all know magnetic flux density. Yeah, I'm getting, madam. Once open the last page. Yeah, Srinivas. Yeah, please kindly note down. Yeah, Shivam Pandey, correct. Flux by area. The unit of flux which passes through the area. The flux by area is nothing but magnetic flux density. I think, I hope, yeah, in the Shena, yeah, correct, ma. I think, have you noted down? I think I will share the PPT. I told you some of the thing you need it while you're solving the problem. But you all know I have shared the entire first and second. Yesterday I shared the second unit, even though I shared the day before where I didn't share your part A and part B question. But yesterday I shared along with part A and part B. Okay, okay. Yeah. Ma. So I will move on to the next page. So flux by area, total number of magnetic lines of force passing through a specified area. I told you my magnetic lines of force passing. If I want to know the magnetic flux density on this particular area, so they will take the magnetic flux, okay, where they will take the specified area, that is called as a flux by area. You all know the unit for magnetic flux density is what? What is the unit for flux, ma? We all know the flux unit phi. Phi by A we were saying, phi by A. The unit for phi is Weber. You need not to write Weber whole. You will write WB Weber per meter squared. Or another one, the scientist which having the high citation, something. Ah, yeah, Rashmita. Yeah, correct. We will use to say Tesla. Okay. You can see some important story behind Tesla and all. He had discovered so many things. You have seen so many citation, and he have so many inventory behind that. So that's why they have kept the unit for magnetic flux density Weber per meter square. I can simply tell Tesla or Weber per meter square. Okay. And this is one of the things. Yeah, very good, very good. Nicholas Tesla and one Tesla equal to 10,000 cars. I'm very happy you people were learning about other scientists and their important stories are behind them. You can see that. Okay. And now we will enter into Ohm's law. Okay, you all know about Ohm's law. I think Ohm's law stating that V equal to IR. We all know. Okay, what is Ohm's law in magnetic circuit? I think did you study this one earlier? Previous slide. Yeah, you didn't study it. Okay, ma. Okay. Some of you have asked to open the previous slide. Okay. You take down the formula for B. B equal to 5 by A and unit is Weber per meter square or Tesla. Is clear, ma? See, in other subject you have completed your, there's like 2 units. Yeah, Karthikeyan, you have written. Yeah, thank you, ma. Yes, ma'am. Okay. So Ohm's law in an electric circuit. My kind advice is it's very, very important thing in magnetic flux. We all know V equal to IR. We all know very well. Okay. Now you just see this is my magnetic material. Okay, any ferromagnetic material or magnetic material. I wound the coil around the magnetic material. Have you seen? Just look out this figure. I have wound the coil and I am applying my DC supply. So once I apply my DC supply, automatically the current will flow. When the current will flow now, any closed path I got, automatically my current will flow. Okay, any closed path, my current will flow. So once the current is flows, automatically this magnetic material will get a property of flux will produce around this. You all know it's an electromagnet. So what happened? It will produce a flux around the core. Okay, so you, if the flux is produced around the core, what happened? You just correlate with this and this. You all know V equal to IR. We all know what is V. It's electric force or voltage or electromotive force or potential difference. Anyway we can represent, but it is a driving force for any electric circuit. Okay, and we all know the current which passes through the electric circuit. And what is the resistance which will oppose the flow of current? Okay, so V equal to I into R. Now you come to Ohm's law in a magnetic circuit. Okay, actually it is very important two more. What is Ohm's law in a magnetic circuit? So same thing, you just see F. F is nothing but magnetomotive force. Okay, we used to say magnetomotive force, MMF we used to say. EMF, electromotive force, MMF, magnetomotive force. Okay, here I am saying voltage, na, electromotive force, that is voltage. Here magnetomotive force. So this magnetomotive force is proportional to the number of coil winding and strength of the current flowing through that. So what the formula for magnetomotive force na, I told you na, MMF equal to N into I. Okay, N into I. Number of turns and current flowing through the coil. Magnetomotive force. Number of turns and current flowing through the coil. Okay, so this is the magnetomotive force is directly proportional. I think I will discuss the formula later, but you have to know what is magnetomotive force. Okay, now once the magnetomotive force produce that, automatically it will produce the flux around the coil. So how I am correlating EMF and MMF? I can correlate the current and flux. Are you clear? So we all know the current will flow through the coil. Similarly, the flux also flows around the core. Okay, some of the flux will be wasted. That is, we used to say leakage flux. But you have seen that they have denoted by here. You all know it's the current means obviously we know it will flow around only the closed path. Similarly, the flux also flows around the closed path, but it's not seems to be that it will flows around the live conductor. But here some of the flux will be wasted. That flux is said to be a leakage flux, but some of the flux which is do the useful work, that flux is called as a useful flux. Okay, so now what happened? I can easily correlate my current and flux. So you all understand in electric circuit voltage now, magnetic circuit, it is nothing but a MMF. Here it is EMF now, here it is a magnetomotive force. Here current now, here flux. We all know? Okay. Next one is, we all know the property of resistance. What is the property of resistance, ma? What is the property of resistance? What is the property of the resistance? Oppose, yeah, Jason, correct. Oppose the flow. Yeah, very good, ma. Anjana, Manasa, Neha, Srinivas, all are putting. So it will oppose the flow of current. Similarly, this is nothing but we used to say magnetic resistance, but technically we use the word reluctance. Reluctance. So what the reluctance will do now? It will oppose the flow of flux. Are you clear or not? So V equal to IR now. Here magnetomotive force is equal to magnetic flux into magnetic resistance. So why I have represented by my air gap? This we used to say air gap. Okay, we are now, so automatically in magnetic material the flux will be very high. But when goes to the air gap, the flux will be somewhat weakened. So that's why here we say the property of the resistance is oppose the flow of current. Here the magnetic resistance or reluctance is nothing but it will oppose the flow of flux. Okay, so V equal to IR, and you kindly note down the formula alone. V equal to IR in yeah, electric Ohm's law, and magnetic Ohm's law is magnetomotive force is nothing but magnetic flux into magnetic resistance, or else I told you resistance, reluctance. The word itself you can understand the meaning. It's nothing but reluctance. Okay, kindly note down important two more. Ohm's law in a magnetic circuit. I think we have easily correlated electric circuit and magnetic circuit. Now we will see the definition in detail. Yes, clear, ma? Okay, have you all noted down? Okay, anyway, I will share this PPT. What I thought till tomorrow. Okay, I will share the PPT. Okay, that's why even though I'm sharing multiple times in the group, because whenever I complete, I will share to you so you can able to study. Okay. Now we can see the definition for magnetomotive force. Okay, MMF, which is cause for the producing the flux in a magnetic circuit. The EMF is a cause for a producing a current in the circuit. So MMF is the cause for a producing a flux in the circuit. So the MMF is proportion to I and N, number of turns in the coil and current flowing through the coil. That's why you people kindly note down the formula for MMF N into I. We all know N is number of turns, I is current. So the unit is what, ma? Ampere turns, or else they simply give AT. Okay, so magnetomotive force is one of the important two mark. Okay, it is a cause for the producing a flux in a circuit, and the MMF is equal to N into I, number of turns into current flowing through the coil. Okay, so number of turns means ampere. Okay, and current is sorry, number of turns is we used to say turns, and current is ampere, so that's why we are getting ampere turns. Okay, that is magnetomotive force. Reluctance, opposition of that magnetic circuit offers to the flux, is called as a reluctance. We all know V equal to IR. So what is the formula for reluctance now? MMF equal to flux into reluctance. You all know the formula for reluctance is MMF by flux. Okay, V equal to IR, how we were correlating now? MMF equal to flux into reluctance. So reluctance equal to MMF by flux. So obviously MMF is inversely proportional to flux. So I can define my flux in two way. Okay, S equal to one more formula. And what is the unit for MMF? Reluctance ma? The unit for MMF is ampere turns, and the unit for flux is Weber. So ampere turns per Weber. You all understand? Ampere turns per Weber is my unit. Yeah. Okay, thank you, ma. And you all know what is the formula for R, ma? Resistance. Don't say the Ohm's law formula. Depending on the material, R equal to. Please kindly post your answers. We have find out the resistance value depends upon the length of the material, resistivity, area. What is the formula that Volt per ampere, no Manas. Yeah, Rashmita, correct. Rho L by A, yeah, Shanmukha also correct. Rho L by A, yeah, you people are not, yeah. Very good, ma. Shrija, Vijay Kumar, yeah, you people have put, yeah, thank you. So, R equal to rho L by A. Similarly, S is also depends on the material. You take the formula L A by mu. Okay, L is the length of the coil, A is the area of the core, and you all length of the core. Sorry, S is the length, L is the length of the core, and A is the area of the core, and nu is nothing but permeability. We will see what is permeability in the next slide. You have take down this formula. Actually, two formulas for reluctance. One formula is mmf by flux, and another formula is L by A nu. And you all understand. Sometimes the questions will be very direct. Defined reluctance. Defined reluctance now you will write it in single word. The material which oppose the magnetic flux offers to the material, the opposition that a magnetic circuit offers to the flux is called reluctance. Or else you can tell it is the ratio of mmf by flux. And sometimes the question is mention the reluctance depends upon the mention the how we can say na, what are the material, what are the parameters the reluctance depends upon. So at that time you have to define it depends upon the length of the core, area of the core, and permeability of the material. And you all know nu equal to nu naught into nu r. I will give the definition in the next slide. I think you people can have seen two things here. mmf is N into I, unit is ampere turns, and reluctance is mmf by flux, or else we used to say ampere turns per Weber, or else L by A nu. Okay. Yeah, I told you, Shanmukh, electrical equivalent of mmf means what? Rashmita, that's I have told you in the previous slide. Electrical equivalent circuit, now, you have seen any electrical circuit, what we used to say. Actually, we have studied two type of circuit. DC and AC we have seen. But you see, I have correlated with the DC circuit where my voltage source is here, and here my EMF, magnetomotive force. That's why I correlated V equal to IR. V equal to IR. Now, here MMF equal to flux into reluctance. Okay, so their voltage potential difference, and here magnetomotive force, that depends upon number of turns and current flowing through the coil. Are you clear? Okay. And you have, some of you asked what is nu. I will explain nu in the next slides. Before that, we will see some definition, and then I will move on to nu. Okay, permeance. What is permeance? Reciprocal of reluctance. Okay, we all know reciprocal of resistance is what? Reciprocal of resistance is conductance. Yeah, Tarunya is correct. Anjana, Indrasena, Bhavana. Yeah, thank you, ma. So similarly, yesterday also in your Kagot we have asked one question. Reciprocal of impedance is what? Admittance. Similarly, reciprocal of reluctance is what? Na? Permeance. Okay. So obviously, what is the formula for permeance? Na? We can say 1 by S. Whatever the formula we will apply, and the unit is what? Weber per ampere turns. Just reciprocal. How we are saying ohm na mo in resistance unit ohm na, here mo. Here reluctance unit is ampere turns per Weber. We all know that is nothing but yeah, we used to say mmf by flux, but permeance is nothing but flux by mmf. That's why the unit is Weber per ampere turns. Okay. And one more important term, magnetic field strength. That is very, how we have seen magnetic flux density, how in the magnetic flux passes through a unit area or a specified area is called as a magnetic flux density. So similarly, we have to measure the magnetic field, whether it is the strongest field or weakest field. We have to measure that field. The terminology is magnetic field strength. You all know the force experienced, how we were denoting that magnetic field strength now. It is how it is measured now, ampere turns per length. How we will measure the magnetic field strength? Ampere turns per length. Ampere turns means what, ma'am? It's nothing but mmf. mmf by L. So magnetic field strength is nothing but it will always use to measure the strong or weaken of the magnetic field. So how we will define the magnetic field strength now? H equal to mmf by L. And you may ask, ma'am, only one formula is there for magnetic field strength? Actually, you have studied one formula. Actually, this formula is new for you, but the another formula, I think anyone can post the answer. Magnetic field strength formula, did anyone know? Yeah, I'm getting some answers. Flux by mmf. No, I'm saying only magnetic field strength. H. mmf is different, H is different. mmf means N into I by A. No. Magnetic field strength, actually this formula is new for you. The another one is well known to you. I think, have you studied hysteresis curve? Hysteresis curve, which loads the magnetic. I think you didn't study. Yeah, BQV Bhavna. Yeah, I will tell you. Yeah, actually, I will show you the formula. I think this formula, B equal to nu into H. I think some of you post the answers. Yeah, Tarunya, very good, ma. Okay, actually this formula is known to you, but the what we learned today is a new formula equal to you. H equal to mmf by L. So we all know what is the unit for mmf, ma? Ampere turns. And what is the unit for length? Meter. So ampere turns per meter. Actually, that is the unit for the magnetic field strength. It is defined as a mmf per unit length. Are you clear, ma? Yeah. Okay. I will show to the, I think you people have take down this formula, but anyway, the formula consolidation is also there. Okay. Now you people see permeability. Some of you asked, madam, what is permeability? I think what is permeability? Before defining permeability, I will show you one thing. I think I will show the next material. Please kindly go through this GIF image. Just you see permeability in a gravel, how long it takes to deliver the water, and you have seen in sand how long it will take, salt how long it will take, and clay how long it will take. In gravel it will take 2 minutes, sand 20 minutes, salt 2 hours, clay 2 days. That is permeability. Then what you ask, what is permeability means? It is the ability of a material to pass the magnetic flux around the coil. That's why I told you here. You have seen nu r. Actually, nu means nu naught into nu r. Okay, the word nu is nothing but absolute permeability. Okay, nu naught means the permeability of air or vacuum. This value is always constant. This never change. 4 pi into 10 power minus 7 Henry per meter. Nu R is relative permeability of the material. So what happened now? If my nu R is less than 1, greater than 1, and is very much greater than 1. You have seen here I can pass only 2 magnetic lines when it is less 1. But here it is somewhat get increased. But if it is greater than 1, obviously it can pass us more number of magnetic lines. That's why they are saying it has a ability to pass the magnetic field around the material. So nu R is a relative permeability of the material. That only decides how the magnetic field strength or how the magnetic field will be created around it. You have seen, I told you some electromagnets and all now. It have a nu R value of around some 1000, 1500, 900 and all. Okay, so you have to understand the relative permeability of the nu R value will be 1 in the air or vacuum. Okay, in air or vacuum, the nu r value is 1. Relative permeability will be 1. But when you take any magnetic material, my nu r value will be depends on the material. So the relative permeability will play a place on choosing the electromagnet. That's why I think this you will understand well. I think this is the best example even given in the Google I have taken from that. So the relative permeability, how they were defining the permeability. So when you see they will choose this type of material only for the electromagnets to create the magnetic field around that. Now I will go to the definition. Okay, permeability is the ability which the magnetic material force the magnetic flux through the given medium. It is the ability. Okay, so that is permeability. Permeability means it is the conductivity of the magnetic flux. You all know the greater the permeability, the greater the magnetic field and greater the magnetic field strength. That's why they have given one formula. B is proportional to H. So B equal to nu H and nu equal to B by H. I think using this only, we will explain the curve, hysteresis curve where, okay. And here you have seen relative permeability of the material, nu equal to nu naught into nu r. So nu naught means nu by nu r. So that's, they were saying that nu r value will be, kindly note down, the nu r value will be 1 in medium. Nu r equal to 1 for air. And nu naught value will be always 4 pi into 10 power minus 7. I think, I hope you have taken this. Esma, you understand? Okay. So my kind advice is, people, please kindly note down these formulas. Very, very important. Why I have consolidated all the terms, all the units, and if you have taken this formula, whatever the problem we can solve, we can able to solve that kind of problems. So people, please kindly note down, even though you write it, because some of you have learning. Fluxna, there are two formulas are there, probable problem, B into A or MMF by reluctance. The unit is Weber or WB Weber. Magneto-motive force, I am having two formula, N into I or flux into reluctance. So I can say my unit is ampere turns. Okay, and reluctance na MMF by flux or L by A nu naught into nu r. So ampere turns per Weber or ampere turns per Weber. AT per Weber, WB, I have given both are this. This is abbreviated one, and this is I have given with the abbreviation. Magnetic flux density, I have a two formula, 5 by A. I think I didn't mention Tesla. That's why how I forgot, who were very important for the think. Magnetic field strength. Okay, B equal to nu H or nu equal to B by H, whatever the thing, or H equal to Ni by L. Permeance 1 by reluctance. Permeability nu equal to nu naught into nu r. Nu r is 1 under the air. Please students, please kindly take down the formula. It's very, very important, ma. Take down this, because why I am saying na, the magnetic circuit, while you're teaching itself, you should have to learn, because I told you this is the very, very easiest unit. Very easiest unit and a scoring unit, because first unit and second unit, you people have thought we are since computer science we are learning so much in electrical. You have to understand that why electrical and electronics is very mandatory and all now. Even though now the IoT is very popular, and you all have to know what are the basic terminology and why we are using and all, you have to know. That's why you are all learning basic electrical and electronics. So how when you take in some foreign universities and all, they always combine electrical and computer. Okay, so a faculty of electrical and computer only they used to say. So that much of have a correlation is there. So even inventing, writing a coding alone is not a CSE subject. Only formulas No big theory, so that is easy, ma'am. Shanmuga. No big theory is there. Actually, this is formulas to solve the problems. Whatever I gave you, why I ask you now, any 2 marks or any problem, this one particular slides will helps you to write. That's why it is very easy for you to people to solve. Okay, I think have you take down? Actually, electrical people will study in detail, but for your people have to know what is magnetic circuit, why it is used and all. So yes, Charan, you have completed. I think most of you have taken this. Yes, ma'am, done writing. Okay. So I think any formulas, anyone can capable to answer. Okay, I will solve some on important some problems. Analogy I will take in next class. Okay, I will take in next class. I think we try to solve these problems. You take down the problem. I think 2 problem I have solved with answer. Next time I won't give like this. I will hide the formulas and all. I think you people first you take down the question. A bar of iron 1 centimeter square cross section. Okay, area is given 10 power minus 4 Weber. I told you 1 Weber is equal to 10 power 8 magnetic lines of force. It is the largest unit. That's why you are in all your problem you will get milli or micro Weber. That's why here also they have given flux equal to 10 power minus 4 Weber. Find the flux density in the bar. Okay, magnetic bar and relative permeability of iron is 2000. What is the magnetic field intensity in the bar? Actually, they asked H. They asked H. Okay, H we have 2 formula. What are the 2 formulas, ma'am? What are the 2 formulas for H? Ma'am, please wait. Wake, you didn't write that particular problem, Salai? B by nu one formula. Another formula? 80. Yeah, Peter correct. Peter correct. Okay, okay, okay. Actually, we have 2 formulas. H equal to Ni by L. I told you this formula when you go on to H, you have to remember this 2 formula. I have Ni by L, B by H. Okay, B equal to nu H. So you have to know I am having only 2 formula. Ni by L and you all know B equal to nu H or H equal to B by nu. But I can't take this formula because number of turns is not given. Current flow the coil is not given. Only length alone given. So obviously I have to go to this formula only. B equal to nu H. Okay. And we all know how to find out B. They didn't give B. So how to find out B now? Find flux density also they asked. So obviously you have to find out flux density. So B equal to 5 by A. We all know flux by area. Flux 10 power minus 4 and you all know centimeter square you have to convert into meter square only. Okay, because Weber per meter square only the unit of flux density, so convert into uh, meter square. So 1 centimeter square now 1 into 10 power minus 4 meter square. So you divide. So what is my flux now? 1 Weber per meter square or 1 Tesla. This is my B value. Okay. So I find out B. I think I hope you all have find out the B value. Find out the B value, ma. Yeah, thank you. Thank you, Rashmita. 1 we have find out. Okay. Next, H equal to B by nu. B by nu. And we all know nu equal to what? Nu naught into nu r. I told you nu is permeability. Nu naught is absolute permeability. Nu r is relative permeability. Higher the relative permeability, higher the magnetic flux will passes through. So you all understand nu naught value you have to able to remember. 4 pi into 10 power minus 7. Pi you have to put 3.14. Are you clear? Okay. Now nu r they have given permeability, relative permeability of the iron. Sometimes they didn't given. Find the magnetic field strength in the air. That means when what is the nu r value? Find the magnetic field strength in the air. Now, what is nu r value? Yeah, Taranya, correct. Nu r is 1. Nu r is 1. At that time, you have to take nu r equal to 1. Or else you choose nu r is equal to, the problem itself they given. Okay, nu r is 2000. So substitute B value, nu naught value, nu r value, and find out the H value. Are you getting the unit for H is ampere turns per meter, 397.88 ampere turns per meter. Yeah, Mohit have put, yeah, you are all getting Indra Sena. Okay. Yeah, very simple. So when you remember the problem formulas, the problem will not much complicate you. It will be very, very simple problems only. Are you clear? Okay. I think you can, next problem also completed, ma'am. Yeah, Mohit, you are for first. Yeah, actually 9:30. Okay, I think I will go through that. Number of turns, 200 turns given, N, and current flowing the coil 1.5. Find the value of magnetic field intensity, H, when the length of the coil is 80 centimeter. Direct substitution. They did, actually I told you only two formula for H. Ni by L only I have to use. Ni by L. You all understand? Number of turns, 200. Current 1.5. Length 80 centimeter. Convert into meter. Again, the unit for magnetic field strength is ampere turns per meter. So convert into meter. Then you substitute all the value. The H value is 375. I think you are all, I hope you are all getting, and almost the time is also over. Bhuneshwari ma'am,
Yes,
ma'am
ma'am.
have joined.
Yeah, she has joined.
Yeah. I think, I hope you have completed the problem. Yeah. Thank you, students. I think I will stop sharing here. We will continue the class in the next hour. People, please kindly go through the unit 1 and unit 2 formulas which I have posted for you. Actually, it is a very lively subject. Please try to understand. Okay. Thank you, ma.